Okay, so there's a couple things we can do with this one. So this one is currently in standard form, right? There are no parentheses, so this is called standard form. So we can go ahead and identify our A, B, and C. As a reminder, ax squared plus bx plus c. Okay, so for this problem, A is 3, B is 5, and C is going to be the invisible 0 that gets added at the end. Okay. So in standard form, right, there's a couple of good things about it. One good thing is that the C value is always the y-intercept. Okay, so without having to do any real math, we can go to the y-axis, and we know that there is a y-intercept at 0. Okay, so again, we got 1 point for free already. Okay, back up here. Another thing we learned is that with standard form, you can do the axis of symmetry. You can find that with the equation x equals the fraction negative b divided by 2a. Okay, so for this problem, negative b becomes negative 5. And then 2a, 2 times a becomes 2 times 3. Okay, so this time the axis of symmetry is a fraction. That does happen sometimes. So what that means, unfortunately, is we probably won't be able to use symmetry for this problem because you can't really tell where to flip it over because it's not going to be a whole number. Okay, so I mean, I will go ahead and draw it in. Negative 5, 6 is between 0 and negative 1. Right, so it'll be like somewhere around here. Axis of symmetry, AOS, x equals negative 5, 6. But yeah, the unfortunate thing is it doesn't really help us get free points. Okay, so yeah, that'll happen sometimes. Now, another thing we can do is we can try to factor the standard form. Okay, so let me just rewrite it over here so it's not as crowded. Okay, so with problems with no constant, no number at the end, that means they both have an x. So we are allowed to factor out the GCF of x. Remember, the x doesn't get, it doesn't vanish, it doesn't disappear, it just moves in front. Then you have 3x squared divided by x would be 3x now. And plus 5x divided by x, the x's go away, you just have the plus 5. Okay, so again, this was standard form. This was the first type of problem we learned. I'll just label it. But once we were able to uh, factor by the GCF of x, this is now in what's called factored form. Okay, so the good thing about factored form is, again, standard form gives you the y-intercept. Factored form gets you the x-intercept, where the graph touches the x-axis. Okay, so here's where you split up the problem into two equations. Okay, and you set each part equal to 0. The reason you set it equal to 0 is so that you can find where the y value is 0, which means it's an x-intercept. Okay, so this is already done. It's the x is already by itself, right? So 0, 0 is going to be an x-intercept. But we actually already had that, right? Because the origin is both an x and a y-intercept. But this one's going to be a little bit different. we want to get the x by itself, we need to get rid of both the 3 and the plus 5. So let's undo the plus 5 first. You do the opposite or the inverse operation, which is subtracting 5 from both sides. Okay, so 3x equals -5. And then now the 3 that's touching the x, that's multiplication. It's 3 times x. So the opposite would be to divide both sides by 3. Okay, so you get an x value of -5/3. Okay, so -5/3 comma 0 will be another x-intercept. Okay, so if it helps you, you can convert -5/3 into a mixed number. That would be equal to -1 2/3. Okay, so past -1, but not all the way to -2. Right, so somewhere around here. Okay, so we got 2 points, right? We got the 2 x-intercepts, one of which is also a y-intercept. But the requirement is always you need 5 points, the vertex, 2 to the right and 2 to the left. Okay, so let's go ahead and set up our usual table, our XY table. Okay, now, again, we always want the middle number to be the axis of symmetry. So yeah, even though this one's a fraction, unfortunately, we have to do it for this problem. Okay, so the vertex will be somewhere on this dashed line. Again, it's not quite at -1, it's a little bit short. Okay, so to the left, we can do -1 exactly. And then we already have -1 2/3. So that's good news. We don't need to jump to -2 because we already have a point nearby. Okay, so again, this point is already going to fill in that row. Okay, then going the other direction, again, to the right of the axis of symmetry, the first x value is 0, but again, we already have that point when x is 0, y is 0. And we just need one more, so the next number up would be 1. Okay, so yeah, unfortunately, fractions do exist, right? Sometimes there's no avoiding it. Not everything in real life is a whole number. Sometimes you got to go in between whole numbers. Okay, so I'll start with -1 though. Just a reminder, you can either go into the standard form or the factored form, right? Whichever one you like better. I'll do the standard form this time. Okay, so to find the y value when x is 1, I'm going to substitute -1 for both x's. Okay, so 3x squared becomes 3 times -1 squared. And then plus 5x becomes plus 5 times -1. Okay, so again, you take the chosen x value that was near the vertex, and then you calculate the y value by substituting in the x value. Okay, order of operations, exponent first, -1 in parentheses squared, -1 times the second -1 is +1. Next, you multiply. 3 times 1 is 3. 5 times -1 is -5. And then 3 minus 5 is -2. Okay, so when x is -1, y is -2. Okay, so again, the bad news for this problem is we can't reflect this over because like you can't really tell where it would land, right? You don't know how far it is exactly from the axis of symmetry. Okay, so yeah, you can't get a point for free this time. You just got to do one extra calculation. Okay, I'm going to jump and do +1. I'm going to save the fraction for last. Okay, so exact same thing. I'm going to plug into the equation again, but this time I'll use +1 instead of -1. Okay, so 3x squared becomes 3 times +1 squared. And then plus 5x becomes plus 5 times 1. Again, exponent first, keep the 3. 1 squared is still 1. 3 times 1 is 3. +5 times 1 is plus 5. And 3 plus 5 is 8. Okay, so we have another point at when x is 1, y is 8. Okay, so we have 4 points. The last one we need is the vertex. So yes, this calculation will be a little bit messier because fractions are involved, but we've all worked with fractions before. We can do it. Okay, so what color haven't I used yet? Pink. Okay, so 3x squared becomes 3 times parentheses -5/6 squared. And then plus 5x becomes plus 5 times -5/6. Okay, I'm going to need a little bit more room. Okay, so again, same as always, you substitute the chosen x value. Okay, so what is -5/6 squared? I might do that calculation off to the side. -5/6 squared means the fraction -5/6 multiplies a second -5/6. Okay, so when you multiply fractions, you just multiply straight across. Top times top, -5 times -5 is +25. And then denominator times denominator, 6 times 6 is 36. Okay, so again, keep the 3 in front, but the -5/6 all squared becomes +25/36. Okay, so now we got to do some multiplication. Okay, what is, excuse me, what is 3 times 25/36? Again, I'll show that off to the side. Okay, so to make everything a fraction, we're allowed to turn 3 into 3 over 1, right? Anything over 1 stays the same. Okay, so now just like the problem above, we could multiply right away. But some of you may remember that it's possible to reduce fractions before multiplying. We couldn't do it last problem because 5 and 6 don't have anything in common besides 1. But for this problem, 3 and 36 can both be divided by 3. Okay, so 3 divided by 3 is 1. 36 divided by 3 is 12. Okay, so that makes the number smaller, right? So now you have 1 over 1 times 25 over 12. Okay, so you get 25 over 12. Okay, and then what about the other multiplication? What is 5 times -5/6? Or let's do the dot instead of the parentheses. 5 times -5/6. Okay, again, I turned 5 to 5 over 1 just so everything's a fraction. This time we can't reduce, right? 5 and 6 don't have anything in common. -5 and 1 don't have anything in common. So 5 times -5 is -25. 1 times 6 is 6. So -25 over 6. Okay, and then lastly, what's 25/12 minus 25/6? Okay, one more time, I'll go off to the side. Okay, so unlike multiplying fractions where the denominators can be different, to add and subtract fractions, you need the same denominator, a common denominator. Okay, so we need to turn these two fractions. They need to be the same number. Okay, so I'm hoping someone remembers. What can we do to make these two denominators match? Yes, Leon? Okay, so this 6, if multiplied by 2, would equal the 12 over here. Okay, so we do want to multiply the 6 by 2, but you can't just change the denominator. You have to change the numerator equally. So whatever you multiply the denominator by, you multiply the numerator by the same thing. Okay, so this one doesn't get multiplied. That one stays the same. But over here, 25 times 2 is 50, and 6 times 2 is 12. Okay, and now that we have a common denominator, we are allowed to subtract. So when you add and subtract fractions, you keep the denominator the same, so it stays at 12. And then you do 25 minus 50. Okay, so again, think about money. You had 25 cents, you had 1/4. Then you owe someone, you borrow 50 cents, right? So you can pay back 25 cents immediately, but you still owe them 25 cents, right? So you're at negative 25. Okay, so the y value is negative 25 over 12. Okay, and if you want to turn this to a mixed number, two groups of 12 would be 24. So negative 2, and you have 1 left over to get to 25. Okay, so yeah, this vertex is kind of tricky. The point is when x is negative 5, 6, y is negative 2 and 1/12. Okay, so this won't always happen from now on. A lot of problems will just be whole numbers, but we do need to practice using fractions sometimes. Okay, so it's a little it's not what we're used to seeing, right? Because most of the points don't have pairs, but you do still have 5 points and you do have the vertex. Okay, so I'm just going to go ahead and label the vertex on the graph itself because that's like a really important point. So we want to have it marked. Okay, so it would look something like this. Okay, so again, I know this problem seems kind of scary because it involves so many calculations. A lot of them were fractions, so it made the calculations more difficult. Again, this won't always happen. It may happen once in a while, but even when fractions are involved, it's all the same steps we did before, right? Negative b over 2a. You factor and set each part equal to 0. You make your table of 5 values and you plug in x to simplify and get y, right? All the steps are the same, even if fractions are involved. Okay, so any questions on this one? Okay, and there's one last change I need everyone to make on their papers. If you could please flip to the third side. Okay, so for the left equation, we don't yet know how to find the x-intercept and the root because it's a decimal, but it's more complicated than normal. Okay, so for that problem on the left, please skip the x-intercept and root. Okay, but you'll still do it for the problem on the right. Okay, so next unit, we'll learn how to do these things for all equations, all quadratic equations. But for now, we haven't learned the strategy yet. Okay, so again, please make sure you made this change because you won't be able to solve it with the knowledge we've gained so far. Okay, so you're going to have time now to practice all of the concepts we've learned so far in Unit 2. Okay, again, the quiz will be very much similar to this handout today. It'll pretty much look exactly like this, just with different numbers. Okay, so this classwork is also the homework. If you finish it during class, great. If you don't get much done, you'll have a lot of homework. Okay, so use your time wisely. Ask for help if you get stuck, and go ahead and get started.